सभी गुरुजनों को होली की चढ़ वंदना।
Thank you, Brijesh, and happy Holi to you again.
All right, great. Very good morning to all of you once again. A very warm welcome to our resource person, Dr. G. Singh Saab. He has already joined us. And meanwhile, let me brief you before we start today's session. Today, we have reached on the sixth theme. It is all about the values in biodiversity conservation and its management. We have scheduled here 6 lectures or 6 sessions for you. And we are starting, the opening speaker is Dr. G. Singh Saab. He is superannuated from AFRI Rajasthan, where he was working as a senior scientist. So in a short while, we look forward to his lecture on restoring degraded lands through forestry interventions. And I would also take this opportunity to wish you all a very, fruitful and a very spectacular World Forestry Day. As we all know, the United Nations General Assembly in 2012 proclaimed the 21st March as the International Day of Forest to celebrate and raise awareness of the importance of all types of forest we have globally. And the countries have been encouraged to undertake local, national, and international efforts to organize activities involving forest, woodlands, trees, and such as tree planting campaigns and other associated activities. In 2022, as you already might be aware, the theme is Inspire for the Future, the role of forest in ensuring sustainable production and consumption. So that is the theme for 2022. I'm sure there are, multiple and parallel activities in your respective universities and institutions and ministries might be happening to celebrate the World Forestry Day. So with these words, I now welcome Dr. G. Singh Saab, and to formally welcome and introduce him, I now invite Dr. Kaushal Singh Saab to please deliver his welcome address and also take this opportunity to introduce him. Dr. Kaushal Singh.
Thank you, Dr. Maheshwari, to give me this opportunity. I think Singh, yeah, join. Good morning, everyone, and I'm very happy to see you, sir, here on this platform. After, no doubt, we are talking over phone, but on by face to face, we are meeting after a long time here. On behalf of organizing committee, sir, are you listening to me? Hello, Singh sir. Hello. Hello, G Singh sir, are you listening to me? Hello. Good morning, sir. Are you listening to me, G Singh sir? Sir, please unmute yourself.
Yes, yes.
Okay, fine.
Yeah. There is some problem actually.
Okay, so maybe some network problem. On behalf of organizing committee and my own behalf, I welcome you, sir. Please, before starting lecture, It is, I would like to welcome you. It's a great privilege and honor to have a great scientist, Dr. G. Singh sir, with us. He is a rich or vast experience in restoration of degraded lands, biodiversity assessment, evaluation of carbon stock in forest as well as soil, tree vegetation interactions, resource conservation and management, including the wastewater utilization. He recently superannuated from Scientist G and Head Division of Forest Ecology and Climate Change and Group Coordinator Research GCR from Arid Forest Research Institute. In short, it is known as AFRI, Jodhpur, Rajasthan. He did his PG and PhD in chemistry from, no doubt, from BHU, Banaras Hindu University. And after that, he joined as a scientist in AFRI and worked here as in various post scientist and SE, SD, E, F, and now he's superannuated from the scientist G. He awarded prestigious awards, so many awards he has awarded, and first he awarded FAO fellowship for 3-month training on recent research methodology in New Zealand. He also nominated for Vishisht Vaigyanik Puraskar from the Ministry of Environment and Forest, Government of India. He's awarded appreciation award from the DDG Sefar Indonesia for his valuable work, and in dry zone he awarded SK Seth Prize continuously 4 times in 2002, 2010, 2017, and 19 for the best research papers in Indian forester in the theme of environmental and ecology. And again, he also awarded Brandis Prize for the year 2018 for the best research paper in Indian forestry and silviculture. So he has many awarded by his name for his incredible research. He awarded ICFRE Award for Excellence in Forestry Research in 2003 and 4. He has more than 3 decades of experience in research and teaching because he supervised so many PhDs there, more than 17 PhDs supervised, and I am also, to be proud, I am also one of them. And he published more than a he has more than double century in publication, in which he published more than 156 research papers, 6 books, and many more book chapters, popular article, and delivered many radio talks. He has concluded more than 33 projects as a PI, nodal officer, or which were funded by World Bank, Ministry of Rural Development, Ministry of Water Resource, Ministry of Environment and Forest, Government of India, Kane Energy, Rajasthan Forest Department, Indian Institute of Remote Sensing, and ICFRE Dehradun. He prepared more than 44 reports, including management plan of wildlife in Jodhpur and DPR of Luni River. So with his brief biodata, I would like to request you, G. Singh sir, to deliver his valuable talk on restoration of degraded lands. Welcome you, sir, once again, and now over to you, sir.
Okay, thank you, Kaushal Singh. And very good morning to all of the participants. I am audible?
Yes,
Hello.
Yes, sir, you are audible, sir.
Yeah, okay. So today's talk of restoring degraded lands through forestry interventions, because we have worked on forestry aspect. The main focus is on forestry and the restoration of degraded lands. Coming to the forest and tree covers in India, this is the recent data published in 2021, and you can see the different categories in assessment year 2019 and 2021, and under the category of different canopy cover, that is very dense forest, that is more than 70% canopy cover, then moderate dense forest, then open forest, and total forest cover is around 21.67% of total geographical area of India. And that excludes tree cover of around 2.89%, total 24.56% area, with additional scrubland in around 1.541%. But we can see the differences between the two assessment years. that is there is increase in very dense forest by 501 square kilometer, but there is decrease in moderate dense forest area by 1582. It is because of the shifting up from moderate forest to very dense forest, or degradation from very dense forest to open forest area. But there is increase in open forest area. It is because of the plantations in scrublands as well as degradation from the moderate dense forest. And this is the category, in which category we have in positive sign, that is increase in different categories or decrease in different category. This data non-forest area that includes 4,992 square kilometer under mangrove cover, and 5 states, namely Andhra Pradesh, Telangana, Odisha, Karnataka, and Jharkhand, showed an increase in forest cover, and other states have shown a slight decrease. And according to the FAO Global Forest Resource Assessment 2020, the world has a total forest area of around 4 billion hectares. That is equivalent to 31% of the total land area. So we can see that this is status of the forest overall, the global pattern are in India. Now coming to the how the degradation pattern is taking place. What is the degradation? This is the degradation is nothing but the loss of productive capacity of the soils. This is land degradations, and it is because of loss of organic matter, depletion of nutrients, or compactions, development of salinity. So many factors are responsible for such degradations. And it is estimated that loss of soil organic carbon at the rate of 212 gigaton by 2050 because of unsustainable land management and land conversion. So this is the UNCCD assessment of 2019. It causes food insecurity, increased in food prices, climate change, environmental hazard, and loss of biodiversity and ecosystem services. Then about 30% global land area is degraded, which contribute to decline in productivity of agriculture land, rangeland, and forest land. And that affects about 3.2 billion peoples globally. So this is the extent of problems of degradations and food insecurity. And out of that, 47% degrading land is forest, and whereas cropland account for about 18%. And grass loss in tropical dye forest during 2000 to 2020 is around 5,61,719 square kilometer. That is 11.4% of the total global area. So this is the extent of degradation in the different sectors. Then coming to dry lands, that is dry lands of India and the world. And dry lands are defined based on the aridity index, which is measure of the ratio of annual precipitation to total annual potential evapotranspiration. And based on the aridity index, the total global area is divided into 6 bioclimatic zones. That is arid, semi-arid, di-subhumid, moist subhumid, humid, and perhumid. And it covers, dry lands cover up to 0.65 aridity index, excluding polar and subpolar regions. And under this category, that is hyper-arid deserts, that is the aridity index of less than 0.05. Then arid, it comes around 0.05 to 0.2. Then semi-arid comes with aridity index of 0.2 to 0.5, and dry subhumid is 0.5 to 0.65. So these are the 3 bioclimatic zones mainly covers the dry lands. And this is the tables. You can see that is annual rainfall in different bioclimatic zone. If it is annual rainfall is less than 100 millimeter, then it is hyper arid, and that is aridity index is less than 0.05. Then arid 100 to 500 millimeter annual rainfall, semi-arid 500 to 850. Then subhumid at 150 to 1000 millimeter, but some country also defined it goes up to 1400 millimeter rainfall annual. This is the area, extent of area in India, that is total 68.1% geographical area of India under drylands. And at global level, total area is under drylands cover around 60.9 million square kilometer. That is equivalent to 41.3% of total global land area. And total population resides in these drylands is around 2.11 billion. That is equivalent to 35.5%. So this is the status of drylands. Then coming to land degradation in India under different process and climate change matrices, that is assessment by Indian Space Application Center, Ahmedabad, and this is a report of 2018-19 published in 2021. You can see that is the different processes of land degradations of under 10 major categories. That is vegetation degradation, water erosion, wind erosion, salinity, waterlogging, frost shattering, frost, that is mass movement, then man-made, that includes mining also, then barren and rocky area, and then habitations. You can see that is a change matrix of 2011-13 and 2018-19 assessment years. And then you can see the change matrix, except that is wind erosion and barren and rocky area, all other categories, then salinity also, all other categories show increase in degradation. Like in vegetation degradation, there is change of increase in around 7,78,113 million, that is hectare area. Then water erosion, that it has also increased. Wind erosion, there is decrease in wind erosion category of land degradation. So that it means there is slight increase in land degradation between these two assessment years. And the maximum share goes to water erosion, that is around 37%, followed by vegetation degradation, that is around 30%. Then wind erosion, that is 18.3%. You can see the different states how there is changes, and the maximum land degradation in Rajasthan, followed by Maharashtra, then Gujarat, then Karnataka, then Jharkhand, then Ladakh area, then Telangana, then Odisha. So these are the major states where maximum land degradation is taking place. And some of the states you can find the change matrix, that is increase in degradation or decrease in degradation. And decrease in degradation you can see in Rajasthan, then Gujarat, then Telangana, and other state you can see that is so these are the states where degradation is taking place, and some of the states showing positive indications of decrease in land degradations, including Rajasthan. So this is the desertification and land degradation map prepared by Space Application Center Ahmedabad, reveals that around 97.85 million hectare land, that is around 30% of the total geographical area of the country, is undergoing land degradation during in 2018-19. And the area under land degradation between during 2011-13 and 2003 and 5 was 96.4 million hectare and then 94.53 million hectare. You can see there is continuous increase in land degradation from 2003-5 assessment to 2011-13 assessment and further to 2018-19 assessment year. That is cumulative increase in is around 1.45 million hectare, that is 4.44% undergoing a desertification and land degradation process. And this is equivalent to 0.22 million hectare per year land degradation in India. And except Rajasthan, Uttar Pradesh, Telangana, all states show an increase in extent of degraded land. So this is the assessment of Space Application Center about land degradation in India. Then coming to the factors responsible for different type processes, that is first one is water erosion. It caused by two main forces, that is raindrop impact and flowing water. An example of water erosions are canyon, that is Great Canyon of Colorado River, then caves, coastal belts, and river banks. And bank of river Jamuna, Chambal, and tributaries, Mahi, Sabarmati, etc. are good example of water erosion in India. In addition, hill slopes are also influenced by both wind and water erosion. Because of the wind activity leads to depositions of sand or the silts along the slopes, and during heavy rain during monsoon period, the washing is taking place of these deposited sands that leads to formations of ravine type of structures along the foothills of the isolated hills. And total affected area in India around 37 million hectare in India affected by the water erosion processes. This is the ravines formation in Chambal river areas. That is different layers, first layer, second layer, third layer type of structures are formed in these ravines area. Then coming to wind erosion, this is also a common problem in the regions where vegetation cover is sparse and wind velocity is very high, particularly in western Rajasthan, northwestern Gujarat, western part of Punjab, and some part of Haryana also, and even in part of the western Himalaya, that is Leh Ladakh area. That is wind speed of minimum of greater than 4 meters per second is required for sand transport, and it is become significant when the wind velocity is becoming greater than 6 meters per second. And total affected area is around 18.24 million hectare in India. And there is some process, you can see that some photographs are here, and these are the processes by which wind erosion is taking place, and then it is how it is become problematic. That is, three processes are involved in wind erosion. Then the first one in suspension, in which the fine particles of less than 70 micrometer size are transported along with the water in the form of transported with wind in the form of suspension, and it goes even a longer period, more than 600 to 11,000 kilometers outward, because the sands of Chart Lake in Sahara Desert are transported to Atlantic Ocean and to go to Northern America, that is up to Chicago. So this is the extent of transportation by suspension processes. The other process is saltation, when the size particles of 100 to 500 micrometer. This process is a jumping process by which small particles are jumping from one place to another in the direction of wind. And the third one process is creeping by higher particle size greater than 500 micrometer, is rolling over the ground and causing abrasions to the ground and further reactivating the wind erosion processes. And this is the process of wind erosion. And then deposition. Right photograph, you can see that this is deposition process, formation of a slip face and two horns and with a top crest positions, and along with it is formed in direction of the wind, and because of the wind direction and continuous depositions of the sand from both the sided here, from this side then this side, and leading to advanced movement of the dunes. And you can see that this is the movement of the falling of the seedlings because of the uprooting and wind erosion process, and falling of the seedling in direction of wind. So this is the direction of the movement of the dunes, sand dunes. Then another third problem processes by which degradation is taking place is the mining activity, and mineral waste are dumped on the adjoining fertile land, creating environmental problems. Fine dust released into the atmosphere also leads to surface scaling and on adjacent land cover. Even fine particles generated during mining while washed down the slope with runoff get deposited in the cultivated fields and restrict the subsurface movement of the water, that is affect the infiltration process and the productivity of the even agricultural land. Then this is the fifth process, that is salinity and alkalinity, and it differs from the normal soil because of the amount of salt and the soil reactions. And the major dissolved minerals, salts in these type of soils are sodium, calcium, magnesium, and potassium are the cations, and chloride, sulfate, carbonate, bicarbonate, and nitrates are anion. And when the concentrations of chloride, sulfate, or nitrate are increasing, it becomes saline. Or when the concentration of carbonate and bicarbonate are increasing, it becomes the alkaline. And then the type of soil, that is a saline soil, when there is a pH maybe less than 8.5, but EC range from 4.8 or 8 to 16 or greater than 16, or category of medium high to very high. And even exchangeable sodium percentage are less than 15. Then alkali soil, that is generally pH is always higher than 8.5, and salinity may be less than 4 decisiemens per meter. And this is the another third category, that is saline and sodic soils, and it is pH and salinity both vary. Then another process is waterlogging and secondary salinity. An area is waterlogged when surplus water is stagnant due to poor drainage, or when the shallow water tables rise to saturate soil pores in the root zone of a crop. It affects productivity by restricting normal circulation of air, declining oxygen levels, and increasing level of carbon dioxide. Then depth of water tables affecting crop may vary from very wide ranges from almost zero in case of rice to less than or greater than about 1.5 meter for other crops. And what are these situations of waterlogging? That is area with water table within 2 meters of land surface is called as waterlog. If it is between 2 to 3 meters or potential area for waterlogging, and it is safe when water table is below 3 meters of the land surface. These are some of the photographs you can see the waterlogging situations in Hanumangarh and Suratgarh area of Rajasthan, and how there is salinity development process because of capillary actions and deposition of salt because of evaporation of the water. Then wastewater disposal is also another problem of land degradations, and Central Pollution Control Board has identified 17 type of heavily polluting industries in India, and these are the cement, thermal power, distilleries, sugar, fertilizer, integrated iron and steel, then oil refinery, pulp and paper, petrochemicals, pesticide, tannery, basic drugs and pharmaceuticals, textile including dye and dye intermediates, then caustic soda, zinc smelter, copper smelter, and the aluminum smelter. So these are the different industries polluting land at very high rates. And there is generation of industrial wastewater and sewage water to the level of 61.75 billion liters and 0.5 billion liters per day respectively. And whereas the installed capacity of sewage treatment is around 21.96 billion liters per day. So we can see what is the extent of untreated water we are releasing to the atmosphere. And some of these industries discharge their effluent into city sewage system, nearby water bodies, or adjoining agricultural land, affecting production and production capacity of our agricultural land also. Then coming to vegetation degradation, this is because of overgrazing and even because of the removal of vegetation by cuttings or illegal cuttings. And you can see what is the
Sir, we can't hear you. I request Dr. Kaushal, please get in touch with sir, and it seems like he has a network glitch. Please bear with us, and we are getting in touch with him to resolve it. Sir is trying to rejoin. Please bear with us till he joins.
Yeah, clear, sorry.
Yes, sir. Yes, sir. Audible now.
So this is the vegetations we were here because of the overgrazing and continuous grazing leads to development of scrub type of structures and scrub type of forest in some of the regions. Then biological invasion is another problem of many of the forest area is invaded by either Lantana camara or Prosopis juliflora, and some of the river breds have been invaded by Arundodonets or Tamarix species.
Sir, sorry to interrupt you. Please go to on slide share mode, sir.
Okay. Okay.
No, sir. Actually, in the slideshow mode, sir, in the PPT mode.
It is not full screen, sir. If you go on slideshow mode, then it will show full screen.
Okay.
Sir, just next to your Zoom in your PPT, there is a slideshow option. Please click on that, and it will automatically come on the slideshow mode. Just next to the Zoom section at the bottom right side corner.
Is it okay?
No, sir, it's still in the.
It's okay, sir.
Sir, you may please carry on, sir. Leave it, sir. I think it's not coming in the
Carry on,
slideshow.
sir.
पता नहीं कुछ स्लाइड शो में जो है इसको स्लाइड्स नहीं आ रही. It's okay now?
Yeah, it's okay, sir. No, carry on, sir.
Then another problems are degraded hills, that is grazing pressure, vegetation removal, and illegal mining are the mounting pressure on already degraded forest, mostly confined to hilly regions. And the lifelong human activity coupled with climatic adversity has made the hills degraded and barren, that is limited to vegetations. And most of the hillocks in the regions are dry regions, are net and exposed to water erosion, resulting in loss of soil and nutrients in addition to invaluable water resources. So these are the another problems. Then this is the sand dunes, mostly confined to western Rajasthan. And you can see the extent of sand dunes in different regions. That is less than 2% in desert of North America, then 11% in Sahara, 30% in Arabian desert, and 48% in Thar desert. And sand dunes migrate constantly. Their rate of movement depends on the size of the dunes, because smaller dunes are moving faster as compared to the larger ones. And some dunes may move from 2 meters to more than 30 meters in a year. And then some of the study indicates that 5 meters in 1 month and a precision of plus minus 3 meters. That is one study done in Sahara area. So this is the extent of desert dunes and its problem associated with the blockage of roads, siltations of canals, and then road blockage, railway line blockage. So many problems associated with the migrations of the sand dunes. Then coming to the consequences of land degradation, that is replacement of forest cover by woodland or savanna grassland, then reduction in species diversity and plant biomass, then accelerated soil erosion by wind and water, then salt accumulation in surface origin of the soils, decline in soil structural stability, then increase in surface crusting and surface runoff, the reduction in soil infiltration capacity and soil moisture storage, then increase in flow variability of the river and stream. That is expected potential of long-term productivity loss is about 10 to 20% because of soil compaction and water erosion at global levels. And it is estimated cost of land degradation is around 231 billions per year, US dollar. That is one estimate of 2016.
Sir, sorry to interrupt you again. Slides are not moving, sir. So, sir, go on the up side and click on slideshow mode. Sir, ऊपर जाइए, देखिए ऊपर आ रहा है slideshow mode. इस पे क्लिक कीजिए सर.
Slideshow.
Yes, sir. Slideshow दिखा रहा है. इस पे क्लिक करेंगे तो सर 1, 2, 3, 4, 5वां है सर ये ऑप्शन.
5वें न्यू शेयर्स में इसमें है एक 5 शेयर है.
होम के साथ लगा है ना सर, होम पेज के साथ. 5th ऑप्शन है ये, जो फाइल, होम, इंसर्ट, डिजाइन, ट्रांजिशन, एनिमेशन के बाद है स्लाइड शो.
इसमें हमारे में नहीं आ रहा है.
सर आपके स्क्रीन पे दिखाई दे रहा है, ये यहाँ से आपका स्क्रीन जो शेयर हो रहा है.
हाँ हाँ,
स्लाइड शो इसमें ये देखिए सर. इस पे क्लिक करेंगे तो स्लाइड शो होने लगेगा सर. फुल हो जाएगा स्क्रीन.
इसमें हमें नजर नहीं आ रहा है.
मूव नहीं कर रहा है स्लाइड, यहीं पे सर रुक गया है.
अच्छा, मूव, इट इज नॉट मूविंग.
नॉट मूविंग सर.
ओके, स्लाइड मूव नहीं कर रहा है.
सर या आप एक ईमेल कर दें तो हम यहाँ से कर देते हैं सर.
नहीं हो रहा है.
ऊपर सर ये स्लाइड शो दिखा रहा है.
स्लाइड शो कहाँ पर है? इसमें प्रॉपर शेयरिंग नहीं है लगता है.
हाँ सर, नाउ इट्स ओके सर.
अच्छा, इट इज ओके.
ओके सर, इट्स फाइन.
Then coming to restoration process, that is net loss of forest area decreased from 7.8 million hectare per year in 1990s to 4.7 million hectare per year during 2010 at the global levels. While deforestation is taking place in some of the area, new forests are being established through natural expansion or deliberate efforts in other areas. The net loss of forest area is less than rate of deforestation, and the global forest area decreased by 170 million hectare between 1990 to 2020. Now, the process 61 countries have pledged to restore 170 million hectare of degraded forest land under the Bond Challenge, but the progress till date is very slow. And forest restoration, when implemented effectively, help restore habitat and ecosystem, create jobs and incomes, and is an effective nature-based solution to climate change also. United Nations decades on ecosystem restoration, that is 2020 to 2030, announced in March 2019, aim to accelerate ecosystem restoration action worldwide. So this is the process of international negotiations to restore our degraded lands. Then coming to the combating desertification in Indian context, that is about zero net land degradations as a goals as one of the innovative way of the world to tackle desertification and land degradation and drought. And it was agreed upon to strive to achieve a land degradation neutral world, addressing urgent action to reverse the land degradations. And there was proposal for sustainable development goals on sustainable land use by all and for all, with target aiming to achieve zero net land degradation by 2030, then zero net forest degradation by 2030, and drought policies and preparedness measures put in place in all drought-prone area. India has already announced in COP14 held in Noida, Delhi, announced by land degradation neutral target of 26 million hectare and is fully determined to meet the target by 2030. And there are so many programs are going on, and some are still in the process of TPR preparations, so that can be implemented to achieve the LDN target. But these are some of the programs are already going on since 1990, that integrated water management in catchment or flood-prone area, the National Water Development Project for rainfed area, reclamation and development of alkali and acid soils, integrated wasteland development, drought-prone area development program, desert development program, national rainfed area. So these are the different programs of India going on. Then what are the processes by which we can achieve this target? By promoting vegetation cover, by afforestation, reforestation of sand dunes, saline lands, degraded hills, then promoting agroforestry, windbreak and shelter belts, then canal sites, roadside plantation, industrial plantations, then stabilizing overburdened and mine overburdened area, then implementation of rainwater harvesting and soil and water conservation measures, then utilization of wastewater effluent in urban area, afforestation effectively, so that we can restore some of the area, degraded areas. These are the species we have assessed in that Campa project, and these are the different, more than 67 species were planted. You can see the extent of more than 10% area covered by species are Acacia totalis. Now it is a Vaccalia totalis, that is 15.3% area. That is followed by Acacia catechu, that is Senegalia catechu. Now 13.7%. Then Vaccalia leucoploia 10%. Then Ziziphus mauritiana 10.9%. And the least species are Terminalia valerica and some of the water loving plants. in this region. So these are the different species and based on adaptability and the area coverage, you can see the species. Then what is the importance of species selections is that is this is a prosperous area in Sahgarh Bulge area of Western Rajasthan, Jaisalmer area. You can see the every stages of regeneration is available for prosperous area, starting from seedlings to saplings, smaller plants, then larger and a big tree. And this is a corner. What is the how prosperous area is regenerating even in sand dune area. So this is the importance of species selection in a particular area. Then coming to soil and water conservation measures, that is an important aspect and an activity that reduce water losses by surface runoff or evaporation and promote infiltration in soil and storage of the water in the soil profile. Then it is a key aspect of economic and environmental sustainability also that covers combating desertification, restore degraded lands and soils, and strive to achieve a land degradation neutral world. This is the UNCCD 2015 report, and these are some of the photographs of rainwater harvesting. Then some of the experimental evidences that you can see that in situ rainwater harvesting enhance survival and growth of tree plantations, and biomass increased by 4 to 5 times over the control, and ring pit and trench and mound measures have been found the best structures for increasing survival and productivity. And ring pit structures, this is the ring pit structures. Then trench and mound, this is the saucers of 1.5 meter radius, not diameter, that is 3 meter diameter. That is ring pit technique is a general use in roadside plantation under MNRGF scheme. So many programs are going on rainwater harvesting measure to establish plantations and productivity of the degraded lands. This is the some of the species planted and how soil how growth performance of different species is taking place, and how soil structures and soil organic matter is taking place. Then some of the process of soil reworking, that is terracing, is applied in nearly level steps along contour, normally by half cutting and half filling procedure. Then terraces are constructed by putting soil upslope from a ditch to form a bund along a contour to make the surface level to some extent. And the terracing of sandy slopes and sand mounds in ravenous sites or mine overburden have been found quite effective in soil and water conservation. So these are some of the photographs, that is terracing of the sandy mounds in ravenous area, and then contour dikes in hilly area to restore such type of degraded land. Then some of the stone lines, stone bonding, rock bonding is also applied to restore the degraded hills. That is, stone are arranged in line across the slopes or along the contour to create bunds, both as a soil conservation measures and for runoff harvesting. And as a line are permeable of water flow, they slow down the runoff rate, filter it, and spread the water over the field, thus enhancing water infiltration and reducing soil erosion. And in steep slopes area of Arauli, Rajasthan, farmers conserve water by constructing staggered stone benches, terraces, which can withstand the lower flow and simultaneously collect rock debris and soil. So these are some of the structures constructed or applied in rocky or hilly area so that they can reduce the surface runoff and promote the infiltration in the soils. Then some of the drainage treatments, this is like check dams, masonry check dams, then brushwood check dams, then loose stone check dams, or Gabion type of structures are prepared. But these structures are continuous, are arranged in such distances so that the bottom of the upper one can fill up and the top of the down one. So by this type of, we can define the distance of preparing or constructing the dams site in a drainage line. Then one system, Khadin system of cultivation. This is a unique structure applied generally in Rajasthan area, Jaisalmer area, and one community, that is Paliwal community, applied this structure. And this is a unique practice of water harvesting, moisture conservation, and utilization for agricultural crop production in hyper-arid region of Rajasthan, less than 150 millimeter of rainfall. And it was designed and developed by the Paliwal Brahmin of Jaisalmer in 15th century for rainwater harvesting on farmland and subsequent use of this water saturated land for crop productions. And in this around 100 to 300 meter earthen embankment built across the lower hill slope lying below gravelly upland, sluice and spillway allow excess water to drain off, and the ratio of farmland and catchment area is regulated to be around 1 to 10, so that a suitable moisture supply is uniformly maintained for utilization in Kharif and Rabi crops, and collecting water in Khadin recharge groundwater and aquifers also, and it provides some of the area as a drinking water supply. So these are the general structures of Khadin system and cultivation it in the bed. Then wind erosion control or drainage stabilization, that is, the different methods are applied, like chemical method, physical method, biological method, depending on the convenience and availability of the materials. In which chemical methods are used, that is petroleum byproduct, that is low gravity asphaltic oil, high gravity waxy oil or crude oil, then chemical mulches like spreading of fine clay, mud and water mixed with the carbonate rich fine clay, and then some are the other sealants which are applied to reduce the surface movement of the sand. Then other process or physical method, it is applied by erection of physical barriers like railroad sleepers, telephone poles, use of oil drums, wall erections, or thatching is also applied, so that we can cover the surface of the sand dunes or sandy area, and we can reduce the movement of the sand or sand drifting. Then third one is biological method, that is plantation of trees, shrubs, seedlings or grasses, either alone or in combinations. And this method, the last one method, biological method, is best effective for control of sand drifting and increasing the productivity of such degraded lands. You can see what is the process, how wind erosion process is taking place in some of the area. You can see the up to height of a man, more than 5 feet of eroded soil, that is leading to exposure of the Prosperity roots. And the second photograph, that is again deposition and formation of sand dunes up to a 2/3 height of a tree, and then depositions of sand in agricultural land affecting the agricultural productivity. So we have worked some of the models, like use of Cassia angustifolia as live micro windbreak in place of traditional mulching by dead material, and it was quite effective in sand drift control. And a combination of Caligonum, that is fog local species, shrub species, and Sonamukhi gave maximum yield and control sand drift effectively. And benefit of Cassia angustifolia are its economic and medicinal value, because it is used in Kayam churn, that is digestions, and Then its phenology is so important because it remains green during summer when maximum sand drifting is taking place, and peoples of this region are now cultivating Sonamukhi in natural stand of Caligonum polygonoides. So this is the technique developed by Arid Forest Research Institute, Jodhpur. And these are some of the photograph earlier, that is mulching, traditional mulching system. Then center one is checkerboard design of Cassia angustifolia itself, and a combination of Cassia angustifolia and Caligonum polygonoides. So this is the species, that is Caligonum polygonoides, and you can see what is the extent of binding capacity of its roots, and that is the root spreading is almost more than 6 times. So what is the extent of mining? And we have estimated that around not less than 100 tons of soils are binded by a single shrub species of this species. So this is the extent of importance of local species in sand drift control, or it is an important species of sand drift. Then canal side plantation. This is the plantation along Indira Gandhi Canal. And this is the eucalyptus, rohida, that is Ticomela undulata, then Gispus mauritiana, Acacia nilotica, Prospiceraria, and so many species have been planted along the canal so that it can reduce the siltation of this canal and maintain the flow. Then we have also worked on rehabilitations of alkaline soils. One of our colleague, Dr. Ranjana Arya, has worked a lot in both in Rajasthan and Gujarat area, and see that indigenous, she applied that indigenous Salvadora persica, Salvadora olivoides, some exotic species like Acacia ampliceps are most suitable tree species, where Attiplex species is better among the statutory shrubs. Different soil water structures where double ridge mound, circular disc mound, and different soils. She has also applied soil amendment of different type, like application of gypsum, then FIM, wheat husk, nitrogen, and all are found effective in enhancing the plant growth and survival. Then use of FIM was best for black saline alkaline soils in Gujarat. And application of fertilizer, phosphorus, zinc, potassium, sulfate, along with the FIM enhanced growth, biomass, and even fruit yield of the plantations like Salvadora olivoides and Salvadora persica. And most important things is improvement in soil property, like in increase in soil carbon, increase in herbaceous species, and decrease in soil pH and electrical conductivity. So these are the different stages of rehabilitation of degraded saline land, that is exposed saline area, then different structures, mound structures, that is circular disc mound structures, and the Acacia ampliceps plantations. Then rehabilitation of waterlogged area. We have also worked on some of the experiment by utilizing the species obtained seeds obtained from the CSIRO Australia, that is Eucalyptus rudis, that is Corymbia, there is Eucalyptus comodolensis, Eucalyptus saligna, Eucalyptus fastigata, and most important, that is maximum growth and biomass was important, regarded for Eucalyptus rudis, followed by Corymbia tessilaris, then Eucalyptus in waterlogged area of Indira Gandhi Gandhi project area. And it has reduced the water table, that is Eucalyptus rudis is most effective in reducing water table by 145 centimeter. And it was followed by Cassia Corymbia tessilaris, Eucalyptus comodolensis, and fastigata by 90, 70, and 60 centimeter. And in lysimeter study, we observed that Acacia nilotica showed higher tolerance towards salinity as compared to Eucalyptus comodolensis. But under waterlogging conditions and at shallow depth, Eucalyptus comodolensis outperformed the other species like Acacia nilotica and Tamarix phyla. Then some of the strategy of restoration of degraded hills, that is some of the restoration work have been done by forest department and in some of the by some NGO. And we observed that pit size of 1 cubic meter and refilling of soil amendment and seedlings planting is most appropriate. Then developing soil retention wall followed by soil refilling, amendment and plantings. Then double blasting followed by soil refilling with amendment and planting. And these are the followed by rainwater harvesting, supplemental irrigation using either spot irrigation or deep irrigations, and even seedlings in root zones of existing vegetation so that we can utilize the facilitative effect of the existing species like Euphorbia, also facilitate restorations of degraded hills or rocky area. So this is the work carried at Siddhanath hilly area, that is you can see, but we observed the problems of root penetration because of there is no crevices in that area, and that leads to some of the mortality in that plantation because of the absence of root penetration. So we are now suggesting that rock blasting so that there should be crack development and some of the water and soils go in the cracks and root can penetrate and utilize that water and nutrient from that area. Our case study of degraded, I am presenting that is a simpler one work carried out on degraded restoration in Banswara area. And you can see the hillocks, what type of hillocks in there at the junction of Palwa Plateau and the Arauli. You can top dome, flat top dome shaped of structures of hills can be visible in that area. And it requires treatment through rainwater harvesting and afforestation to restore them and support agriculture in foothill and pavement areas. So these are the some of the structures were prepared like contour trench, cradoni, V-ditches and box trenches, and the species planted were Acacia catchu, Azadiresta indica, Dendrocalmus strictus, Ablica officinalis, Melina, Holoptelias, Syzygium cumini, and Gygipus mauritiana. So this is the plantation, this is the hillocks, plot after plantations. This is the how plantation activities which was going on. That is pitting by 45 centimeter by 45 centimeter. Then scraping of top organic matter rich soil, putting to the half fill to the pits. Then plantation of the seedlings, and then preparation of a small micro catchment so that we can harvest the rainwater in vicinity of the root zone of the planted seedlings. Then how the rainwater influence the plantation, that is stored water in a rainwater harvesting is seep to the root zone of the plants and influence its growth and enhance the growth and productivity and the regeneration of many of the flora in the area. Then this is the different growth, so taller and thicker plants in different slope category, that is less than 10% slope is better for plantation activity. But performance of Holoptelia integrifolia was better in the plots situated in 10 to 20% slope category. And growth of Acacia catchu was highest in greater than 20% and less than 10% slope because of the clay nature of the soil in these slopes. And these are the, what is the different species, how the different species are performing under different slope categories and in different rainwater harvesting structures. You can see the first species, Dendrocalmus strictus, is performing well in less than 10% area and under contour trench rainwater harvesting structures. Then Acacia catchu, it is also performing well in less than 10% and under V-ditch VDG structures. Then Acacia diresta indica is also performing. The most of the species are performing well in less than 10% slope, except Holoptelia integrifolia. And some of the in rainwater harvesting structures, Dendrocolmus strictus, then Amblica officinalis, then Holoptelia, Syzygium cumini, Mauritiana are performing well with contour trench rainwater harvesting structures, whereas Acacia catechu and Azadiresta indica performed well under VDG structures. And one species, Melina arborea, was performing better in condition of box trenches. So we can see how the species are performing in different rainwater harvesting structures and different slope. According to, we have to select the species and to select the particular rainwater harvesting structure for better growth and performance. So this is the, you can see why different species are performing in different type of rainwater harvesting structures. You can see the Acacia catechu show different type of rooting structures, that is surface feeding structures, roots, as well as the bottom feeding structures. In Acacia senegal, most of the roots are surface spreading. Then Acacia peruviana, also most of the roots are surface spreading. In Melina arborea, also most of the roots are surface spreading. So the species which are having surface spreading roots are better performing in VDG type of structures. Then rooting in Zygipus mauritiana, then Amblica officinalis, Holoptelia integrifolia, Zygipus nemularia. You can see the most of roots are deep penetrating, and why these species are performing well under contour trenches. So this is the another Prospiduliflora and some of the other species, how they are spreading their roots. Or this is the area under in 2010 and 2013, and these are the some of the photographs taken by Kaushal Singh itself. Then there is a significant increase in fine earth fraction in the soil as compared to 17% in 2005. The increase in nutrients availability, then in decrease in nitrogen concentrations were lesser in some of the area, and then increase in soil organic carbon. And it is also vary with the different type of rainwater harvesting. That increase in soil organic carbon was by 12.2% in box trenches to 28.16% in contour trenches. Then what is the impact of afforestation and rainwater harvesting? You can see how the soil structure is, why soil formation is taking place from almost gravel to the soil formation. You can see the different variables we have observed, and what is the trend. Runoff collection decrease by 2% of the total rainfall, that is around 1000 millimeter annually. Soil losses decrease, nutrient losses decrease, soil water increase, that is the soil bulk density decrease, fine earth fraction increase, soil nutrients increase, soil carbon decrease. Hello. So these are the some of the parameters. You can see that is which parameter that increase in herbaceous diversity, diversity of regenerant fauna, fodder availability, and water availability. So this is increase in diversity of herbaceous vegetations. And you can see in different year how number of species are increasing. Then this is the diversity variables. What is the impact of rainfall, annual rainfall, and what is the impact on different number of species, population, vegetation height, species diversity, dominance, richness, and evenness. And that is, you can see even the effect of rainfall on vegetation growth and population. Then vegetation productions, you can see that is the different type of structure. What is the growth of that is Thymeda, Quadrivallis, and Hectopogone contortus. Then how different harvest dry biomass and species dominance. We generally observe that diversity enhances biomass productions, but we observe species, that is species dominance in herbaceous species dominance was more important factor to increase dry biomass. And that is two factor, herbaceous vegetation, that is dominance, and vegetation height. Both are showing almost linear relationship with dry biomass production. Then even carbon sequestration, we observed that very almost linear increase in soil organic carbon with increase in soil water content. This is the total carbon stock, that is number of species is showing almost increasing trend with total carbon stock increase. That is both herbaceous shrub species and tea species showing linear relationship, whereas herbaceous species does not see almost, it is almost same pattern because of the annual pattern of their growth. So these are the some relationship of how annual runoff and relations, runoff and soil losses, then annual runoff, then water and nutrient losses. This is loss of nutrients, either phosphorus, nitrate, ammonia, and that is all the nutrients are in soil are increasing with increase in amount of surface runoff. Then how water quality is influenced by diversity, that is you can see that number of species showing that if number of species are increasing, it shows decrease in soil loss, that is decrease in salinity of the water, then decrease in pH of the water going through surface runoff, even decrease in soil losses. These are the positive indications of diversity increase on water quality improvement. So this is the different, what is the variables, that is different variables, soil losses, and this is extent of quality parameters of runoff water. This is the relationship in rainfall and soil water content during June and December. And you can see during stress period, it shows better relation as compared to less stress period or post-monsoon period of December. Then rainfall is also, you can see that is increase in rainfall affect dominance in increasing with increase in rainfall, whereas diversity is increasing with increase in rainfall. This is increase in diversity of the restored area. And coming to the restoration process and the cost of restoration, we can see that this is the most important process, that is starting is prevention. If we are preventing, that is the least cost. And when it is increasing, that is protection and assisted regeneration, then protection, site clearing, seed sowing, then resource conservation to mitigate and cure, and the rehabilitation and reconstruction. It increases the cost of restoration and increasing the environmental conditions. So this is the, what is the best choice is we have to prevent land degradation in initial stages, also that we can reduce the cost or we can spend minimum amount of money. By this way, we can support the livelihood of the local people, what we are talking about sustainability. So this is the fodder productions and people are collecting fodder from that area. This is fuel wood collections from the area. And this is the water availability and visit of the animals for drinking purposes. So this is the whole about the type of degradations and different type of degradation processes and how we can restore and increase the vegetation cover and forest cover by restoring different type of degraded lands. Thank you very much. Any questions?
Thank you, sir, for sharing your vast experience with our participants. No doubt our participants will be enriched with your experiences, and you so very beautifully your vast work which is done by you in your last 3 decades in Rajasthan. So as usual, we have some question in chat box also, but first I would like to request all the participants, if have any question, please ask. Now session is open for asking question.
Sir, one my question.
Yeah, Dr. Bridges, please ask.
Yes. Sir, which is best tree species for sand dune stabilization in Rajasthan desert?
By now, best species is Vaccalia tortilis. This is exotics, and from Israel, it is also called Israeli bubbles. But we are now in the process of its subsequent, that is sequential restoration, so that we can avoid the exotics. First, because there is no species choice, we have applied that. Even Forest Department has applied that. But we are now recommending to replace that species, because the objective on which these species were planted have been achieved. Now we are in the process to increase the livelihood, so that we are going for replacement of these species with some of the indigenous species, like Geophas and Caligona polygonoides.
Yeah, no doubt, sir. Now there is a interest to harbor more native species and focus on the native flora, because native flora have wider adaptability and more number of ecosystem services as compared to the exotic species. Thank you, Birjesh, for asking question, and I think you are satisfied now. And more questions from, I think should ask our participants, because this was a very interesting presentation. So more from the other participants, please ask the question. I think yes, there are 2 questions in chat box, sir. We can discuss it. Dr. Garima Gupta from Central University Jhansi, she is asking, soil conservation is one of the ecosystem services. Sir, how to quantify as money value the ecosystem services of soil conservation?
We can quantify in money value, that is the replacement cost method. And suppose soil without soil conservation, there is a lot of silts are deposited in a drainage line or ponds. When we are applying to desilt that amount, what is the expenditure involved in desilting process of either drainage line or the pond? That is economic value of that. So by that way, if we are conserving or applying any rainwater harvesting structures or soil conservation methods, what is the extent of reduction in silt losses or nutrient losses? We can calculate indirectly the cost of soil loss or nutrient loss in terms of fertilizer applications or in terms of involvement of labor in desilting processes.
Okay, thank you, sir. Next question from Dr. Shwapna. I think Dr. Shwapna, you can ask directly from sir.
Okay, sir.
Yeah.
Good afternoon, sir.
Good afternoon.
Sir, are there any agroforestry techniques to reclaim acidic soils?
Agroforestry is nothing but plantations. Plantation is also agroforestry. It is not only agriculture. Agri-silvi plantations, shelter belt plantations, boundary plantations, all are a part of agroforestry. So I have one slide. I had showed one slide. So many experiments was carried out by Dr. Ranjana Arya, one of my colleagues, and she has worked in Rajasthan, that is inland drainage system or inland saline area, as well as in little run of Kutch. And she has applied so many species, either exotic species, and she has applied also some of the indigenous species. The indigenous species like Salvadora persica and Salvadora ovoides, and in which Salvadora persica is more tolerant to salt stress. So these are the plantations. By some of the amendment like gypsum, if alkalinity is more, we have to apply the gypsum. And if salinity is more, then we have to apply some of the leaching process so that we can reduce the stress of salt by leaching processes. So by this way, we can rehabilitate saline or saline alkaline water area or alkaline area. Okay. Or by selecting suitable species like Acacia amplisex, Acacia cynophila, some of the Australian acacia are important species. Okay.
Okay. Thank you very much, sir.
Yeah. Thank you, sir. Next question is asking Dr. Yumnam Vijayalakshmi. Please ask the question.
Okay, sir. Thank you. Sir, I was thinking like using the chemicals like gypsum, lime. Sir, is it feasible to use it directly in the forest soils? Like, can we use it? Because, or is it feasible, or is it, what to say? I'm not able to take it. Will it be useful?
Yes. Yes.
Because sir, it will be in a big broader area, like in a forest soil, and using these chemicals, and it will be a season wise. Now, sir, if we apply once, then it won't be useful for whole like at the time. It will be used in seasonally. But if we apply in the forest soil, will it be like I'm not getting that term.
Eco-friendly.
So I'm getting my question. Yeah, eco-friendly also, sir. Like I'm not getting that. Like if we are applying now, then will we be getting that enough advantage or these that we will be getting from applying that chemical?
In fact, gypsum is it is not a chemical. It is also excavated in the soil itself.
Yes. Okay. And
application of gypsum is generally provided to one anion, that is sulfate. So, and another anion is calcium. Calcium is reducing the toxicity of sodium, whereas
yes,
is causing reduction in pH. So both way and quite useful.
Okay. So, sir, it is feasible that we can use these gypsum and all in forest?
People in Rajasthan, even they are farmers are applying.
Okay, sir. Thank you so much.
Okay, thank you, Yumnam. Next, please, any participants have any question?
Hello. Hello.
Hello. Yes.
Hello.
Yeah, Dr. Ashok.
Namaskar, sir. Sir, I have a small question. Which is the best tree species for sand dune stabilization?
Or just Ashok, this question, sir, Dr. Brijesh.
Already पूछा जा चुका है और मैंने बता दिया Acacia totalis, that is Vaccaria totalis, and shrub में है Caligonum polygonoides, Acacia jackmonsai. Both are the indigenous shrubs, are very effective in sand drift control.
और सर मैं सुन नहीं पाया था तो डिस्टर्बेंस हो गया था नेट की वजह से, तो एक छोटा सा क्वेश्चन था मेरा आपसे.
So I think there is no more questions. Thank you, sir, for sparing your valuable time and enriching us from your vast knowledge. I have seen how a core chemist converted into a ecologist come taxonomist, and I'm very happy to see you again here, sir. And now I would like to request Dr. Aishwarya Maheshwari to give a formal vote of thanks to sir.
Thank you, Dr. Kaushal. Sir, it was really wonderful listening you and learning from your valuable and incredible experiences on the ecology and forestry. And I must say that there could not be a better speaker and a better presentation to have on the occasion of the World Forestry Day, today, 21st March. You have, taken us on a remarkable journey on the ecological restoration, the methodologies, and with particular emphasis to these arid and semi-arid biogeographic zones where you have worked for more than 3 decades. It was really wonderful, sir. And on behalf of the organizing committee and my own behalf, the Banda University of Agriculture and Technology express the sincere gratitude and very thankful to you for accepting our invitation and enlightening us with your session on the ecological restoration. With these words, sir, we look forward to your similar cooperation and guidance for upcoming academic and professional programs of the university. So thank you very much, sir.
Thank you very much.
Thank you, sir.
Thank you all.
So, dear participants, that was a very remarkable lecture on the session of ecological restoration on World Forestry Day. So we have scheduled 2 more sessions in the second half, and we will assemble here at before 3 p.m. And we are really looking forward to 2 of the very important sessions. One is on the human-animal conflicts, and there could not be any better presenter than Dr. Vipin Chaudhary Saab. He is the network coordinator for the AINP in the ICR coordinated project, and that would be followed by our very beloved Dr. Alok Saxena Saab. We have already heard him on the island biodiversity, and today he will be talking about the mangroves in India and overview. So 2 very important sessions in the second half. So we look forward to your similar enthusiastic and interactive participation in the second half. Thank you, and see you in the post lunch.